As Kermit and Friends might say, it's time to play the music, it's time to light the lights, it's time to talk some AppSec on the AppSec Show tonight, or today on Monday. Because this means this week we talk with Andrei Serban from Fuzzbuzz about strategies for building tools for devs to use, targets for devs to fuzz, and fuzzing results that drive higher quality software. In the news segment, attackers siphon source from misconfigured SaaS. Surprise. Attack on Titan scours keys for secrets. Low-quality software saps security budgets. 7 DevOps domains for adoption, and more. Why don't we get things started and stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Security teams need visibility into Linux systems to detect and investigate incidents and protect against unwanted activity. Operations teams are not down with downtime, and with revenue tied to uptime, ops priorities are enterprise priorities. Which is a higher priority? Why not both? Capsulate provides flexible, production-ready infrastructure protection for Linux systems, all without a kernel module. With ops-friendly production security, Capsulate delivers monitoring, detection, and response without adding operational risk or cost. Visit securityweekly.com/capsulate today to request a demo. In a fast-paced tech environment, the potential attack surface increases with each release and new app created. Detectify automates cutting-edge knowledge from trusted ethical hackers into the development pipeline for reliable application security. Go beyond the OWASP Top 10. Check your web apps for over 2,000 known vulnerabilities actively exploited in the wild, monitor subdomains for potential takeovers, and remediate security issues in staging and production. Learn more with a free trial at securityweekly.com/detectify. Go hack yourself.
This is episode 136, recorded January 11th, 2021. I'm your host, Mike Shima. I'm here with Matt Alderman. Hello, Matt, and Happy New Year.
Happy New Year. Go Bucks. Do you know the response to OH? Sorry, it's the championship game tonight.
Sorry, what were you saying about how cool Penn State is? I missed that part. We also have with us John Kinsella. Hello, John.
I've got no horse in this football thing at all.
Well, we've exhausted my football knowledge at the moment anyway, so it might as well be a good time to read some announcements. Do you all want to stay in the loop on all things Security Weekly and college football? Visit securityweekly.com/subscribe to subscribe on your favorite podcast catcher or our YouTube channel. Sign up for our mailing list and join our Discord server. You could be talking with us live right now. We have officially wrapped up all of the recordings for our 2020 webcasts and technical trainings. Stay tuned as we build out our schedule for this new year. Visit securityweekly.com/on-demand to view all of our 2020 recordings. Andrei Serban is the CEO and co-founder of Fuzzbuzz, a security startup based in San Francisco that builds fuzz testing tools and infrastructure to help developers find severe vulnerabilities and bugs in their code with minimal effort. Today, Fuzzbuzz works with some of the largest tech companies to reduce the number of vulnerabilities that make it into production by enabling teams to fuzz test as part of their DevSecOps pipeline, finding bugs as soon as they get introduced. Andrei studied computer science at University of Waterloo before dropping out to start Fuzzbuzz and accept the Thiel Fellowship. Hello, Andrei. Thank you for joining us.
Hey, happy to be here.
We're happy to have you. And as I introduce you, there's some neat things about fuzzing, and we've talked about fuzzing quite a bit over the past year or two here. But one of them is that we can use fuzzing to find severe vulnerabilities and bugs, and you do so potentially with minimal effort. But that minimal effort maybe not always be true. So why don't we start there maybe with a little bit of just what is fuzzing and how can we make fuzzing easier to adopt? Because I also want to say not everybody's doing it right now.
Yep, totally kind of right on the ball there. Not a lot of people are fuzzing, and I think the largest hurdle to mainstream adoption for fuzzing comes from just the ability to actually start and kind of write some fuzz harnesses, some fuzz tests. I think that process is kind of the last thing that needs to be worked on. I think there's been a lot of fuzzing research that's proven that fuzzing is a very effective technique, We just haven't gotten it to the point where it's something that every developer can do. And so backing up a bit, what fuzzing actually is and the way it works, which I think a lot of the viewers are familiar, so I'll kind of just quickly go over it. At least the way we do it, we call it coverage guided fuzzing. And so the idea there is you have your application and you have your fuzzer, and your application gets instrumented at runtime, or sorry, at compile time with some flags to be able to give some coverage data back to the fuzzer. We kind of expand on this idea and send other types of data back to the fuzzer, but we instrument this application and then we run it. And then the fuzzer will send random data, random inputs into your application. Your application will then process those inputs and send back to the fuzzer kind of what happened when that input was being sent in. The fuzzer will then take that input and kind of that data and then kind of generate a new input based on that. And so the way that I like to think about it is like playing a video game. If you play a video game and you have to restart to the beginning every time you die, it's going to take you a really long time to get to the end of the game. But if you're saving along the way and you're kind of just incrementally getting a little bit closer, then you're going to finish the game in a normal amount of time. And so coverage guided fuzzing is kind of similar in that sense. It's incrementally getting deeper and deeper into your code by just trying random stuff, but saving the interesting ones and building further off of those.
Yeah, no, that's a great overview, and it's helpful to also think. The video game's a good analogy. So you finally get to the end to find out only that the princess is in another castle. But in this case, it's not completely random. All of the way it's building these intermediate save states, so to speak. There's relationship here to perhaps unit tests, or the way that you mentioned too. I think a little bit guided coverage. So there's a little bit of focus here about how a fuzzer can get to a point that causes a crash. And I think part of that perhaps ties into, how efficient is it to run a fuzzer to find these types of vulnerabilities, or what types of vulnerabilities is it going to be able to find?
Yeah, so the way we think about fuzzing is kind of, if you're familiar with like kind of the known, known unknown kind of framework, right? Known knowns are the things that your developers know. They expect to break, they expect things to happen. Known unknowns are things that, they expect might happen, but they're not quite sure how or where they manifest. And so known knowns are things you're testing, things like unit tests, any kind of like developer written test. Known unknowns, you probably want to employ something like a static analysis tool or something like that, where the static analysis tools are just looking for existing bugs or things that have happened in the past and just kind of pattern matching your source code to any patterns that have been vulnerable in the past. Where fuzzing really shines is in the known unknown unknowns, right? It's the things that no one knows can happen, right? And the reason it's really effective in that situation is because it is random, right? It's coverage guided, but what I mean by that is that it will just randomly flip bits. It'll just randomly insert characters and append things, slice things, just do whatever it can with those inputs. But the thing is, it saves the interesting ones. The interesting ones are the ones that cover new code paths. They get incrementally closer to finding, kind of getting to 100% code coverage. And that's kind of the goal there with the fuzzers is they're guided by coverage. They're trying to just get as much kind of coverage as they can inside of your application. And so because of that, it really shines at finding these kind of edge cases that developers tend to miss. And so fuzzing has traditionally been very effective at finding memory leaks, crashes, hangs, any kind of undefined behavior or assertion failures, which make up a large part of kind of like the typical CVEs that you get. We're trying to expand the class of bugs that fuzzing finds. And so we do that through a variety of ways, but largely just kind of employing, some of that static analysis kind of pattern matching tooling, detecting areas of your code base that could be interesting to fuzz, and then fuzzing against those areas specifically. Again, the thing to remember with fuzzing is the fuzz engine is only going to be as effective as you make it. It's by default going to look for anything that looks like a bug, right? And a bug is a crash in every case. But if you take a more complicated kind of business use case, right, where you have a bank and you're transferring $10 between two accounts, the fuzzer will send that $10 over. But if actually, $1,000 got sent over, the fuzzer has no idea that's wrong, right? And so you need to tell the fuzzer what a bug is. And so that's kind of the process that we think will unlock kind of more larger adoption of fuzzing is what kind of class of bugs can the fuzzer find? And the way to do that is to tell the fuzzer, these are bugs and these are not. And kind of like invariants, right? If you've ever done like property-based testing or something like that.
Andrei,
Go ahead.
Yeah, I was going to say, one of the challenges with application testing in general is kind of the business logic piece, right? Interactive testing has tried to address aspects of the business logic and inserting that into the test case. What you just described sounds like you're also trying to do some of that business logic at the fuzzer as well. So if you potentially can find some of these like logic bugs earlier in the process.
Exactly. Yeah. So the idea is that a lot of the time fuzzing is kind of done at the audit stage, like security audit stage, which happens, once a quarter, once a year, whatever. We think fuzzing should be done continuously. It should be in your DevOps pipeline. It should be run all the time. Anytime you make a PR, anytime you make a new push to main or master branch, right? Like these things should be kind of actively being fuzzed, and because they're changing, right? Like when your code base changes and you're you're releasing multiple times a day, these are all kind of potential introduction of new bugs. And so the kind of core thing that we do is put this into the DevSecOps pipeline, and then you're checking for these logic bugs. And so as long as you can tell the fuzzer, like, this property always needs to be true, then the fuzzer will detect if that property isn't true, right? And so that, a really good example, kind of like I said, is crashing, right? The property needs to be that the application is running. If the application crashes with kind of like a bad exit code, then that's clearly a bug, regardless of the software that you're writing.
Yeah, I think to help expand on that idea too, that we're talking about business logic, those types of vulns, and it's not just to say fuzzing. If you have a memory unsafe language, just use fuzzing. It's more, I think, if you want to go track down some of those complicated business logic, or even also concretely, what are you parsing? We've seen fuzzing being used quite successfully against parsing of images or PDFs or that type of user-generated content, as well as even protocols. Protocols are great for fuzzing because they have ostensibly a state machine that you're supposed to go from this state to this other state. Here's some well-defined transitions, but maybe the RFC is underdefined, or the RFC is misinterpreted or misunderstood, or just implemented off. So all of these things, I think that business logic, parsers, protocols, these sound to me like great things to go and start fuzzing. I'm curious, looking either at this group that I just kind of enumerated or some other types of code, have you found some particularly interesting vulns that pop up that could just kind of highlight what it means to benefit from running fuzzers against various types of code?
Sure. So I got to be careful with, I guess, how much I say, but so these are kind of real bugs that we're finding on some of our customers, the ones that are running on our hosted version, at least. Typically, so I think kind of the more interesting ones that we found, we did find a kind of vulnerability in kind of like a medical device protocol. So medical devices don't communicate over HTTP or they have Bluetooth and stuff, but they use random protocols, kind of grammars, kind of like JSON, but like specific to the medical industry. And so like HL7, DICOM, and then there's very specific ones that large medical kind of companies will kind of have just defined internally so that their devices communicate over this weird protocol as well. So these things are typically so obscure that there isn't like a common framework that you can just pull into your language. Like every language has an HTTP framework that's kind of more or less standard, and it's really well tested. And the HTTP kind of RFC is really well understood as well, and people know how to test that and make sure things are working. With some of these more obscure protocols, it gets a lot trickier. And so you have these really kind of long, crazy specs that are getting implemented kind of custom by each company by their own developers. And they will often have mismatches between versions and stuff like that. So that's a really good use case for something that should be fuzzed. And we found some pretty interesting vulnerabilities there that kind of, just in the parsing logic code and the way the inputs get processed by the application. Again, they're parsing them incorrectly and then passing them along to the logic part of their applications. And we found some bugs that lead to RCEs, that lead to kind of memory leaks that you can then kind of read data from the buffer and stuff. So there are some pretty severe vulnerabilities there. In the more kind of non-traditional case, right? So fuzzing is very traditionally really good at crashes, memory leaks, and so on. We have found some interesting bugs where If you're fuzzing two applications at the same time that should be implementing the same spec, but they kind of differ in their implementations, right? So this is really a common thing to fuzz in crypto, either cryptocurrency or cryptography kind of industries, where you have a kind of implementation that you want to build a separate implementation of, and you want to make sure that the inputs are kind of processed the same way. So we find a lot of vulnerabilities there as well, where, if you can find that an input is processed differently in by a crypto library, that can lead to a lot of serious vulnerabilities as well. And then lastly, we have found a lot of vulnerabilities in like databases. Databases get really complex, right? They're distributed, they're processing a lot of kind of code, they're high frequency, like they're going really fast and stuff. So you get a lot of interesting vulnerabilities there. Again, more on the side of like crashes, timeouts, and incorrect parsing of like SQL, especially when you get to the really, really crazy SQL statements. You get some really interesting use cases there.
So that's neat. And what you're saying is that you rattled off a couple instances where you're talking about some RCEs, some nasty vulnerabilities. But I think that then too, you're saying, a crash is a crash. And I'm going to foreshadow a little bit. We're going to be talking about software quality in the upcoming news segment. But I think what I'm getting at here is that if you're running a fuzzer and the target crashes, that's actually something to fix. So it's very rarely the case that you're going to get false positives, so to speak, out of fuzzing, right?
Right. So that's kind of I think the most interesting part with fuzzing compared to some static analysis tools or CV scanners is the application that you're testing is actually running instead of just scanning the code. And so that leads to results that are much more actionable. When we report a bug to a user, we tell them, look, this input triggered this stack trace. Here you can go and download it. You can go and look at the state of the application when that happened. We'll actually also try and reproduce that bug ourselves about 5 times, and then let you know how many times you're able to reproduce it. 95% of the time, we're able to reproduce it, 5 out of 5 times. Sometimes you get into state kind of situations where it wasn't the last input that triggered the bug, but it was like the previous 2 or 3. And then in that case, that's where you want to start employing some snapshotting. You want to run the application with debug symbols, so you can give the user an exact kind of debug state snapshot, and then they can go in and look at the exact state that triggered the bug. But for the most part, they're very reproducible. Again, if your application crashes, it's here's the input that caused that crash. So it's very straightforward in that sense, compared to some static analysis tools where it gets a little trickier to detect, like, is this code actually being run this way? It's because it's just scanning your code. So because of that, we think it's really powerful. We're constantly looking at ways to improve the types of bugs that you're finding, because again, they're more actionable. They're more they're less likely to be false positives. So it's really interesting to see what other kind of classes of bugs can we find on a real live kind of running application.
Andrei, the scanners will say, well, I don't need any instrumentation to do what I do, which is scan, statically or dynamically. How difficult is it to instrument one of these applications to get the benefit out of fuzzing? Is it a big lift, or is it pretty straightforward when it comes to the implementation side? Because I think to get to that coverage, you need a little bit of that insight, right? And so if there's too much friction, then maybe the developers don't put that instrumentation in place. What's that like?
Yeah, so that's definitely, I think, it's definitely the largest problem in the fuzzing community so far. We've got some solutions that we will be launching this year, where basically we help developers, familiarize themselves with the tooling and have a better understanding of how it works, and then give them the tools as well to just instrument much easier. So typically, if you want to instrument your application, you need to change your build steps quite significantly in order to account for that. So what we can do is, with most languages, I'm going to put an asterisk there for C and C++, where I think, unfortunately, that's something that might take us a while to tackle. I think, we typically, with C and C++, it's harder to infer things. But when you're looking at languages like Go, Rust, Python, C#, Java, these are really easy to infer. And so what we do is we basically just take your standard build steps that you use to build your application as you launch it to production, and we try to instrument just based off of that. So we're actually not, for certain languages, we're not requiring the user to really modify their build steps at all. And then I think that's a pretty big breakthrough, because typically, there was a heavier lift involved. And so we've seen some of our customers take, so depends on the scale of the company and depends how kind of the large the code base is. We've had some really large databases that kind of onboarded within 2 days. And really that was mostly actually bugs on our side, just being able to handle their scale. Actually instrumenting the code was not the difficult part. And so we've seen kind of on the medical device side, right, those get a little bit more complex. There's multiple pieces, moving pieces and stuff. Those will take about a week to integrate. But once they're integrated, right, there's no more work that the developer has to do on the instrumentation side. Then the developer just has to write a fuzz test, which we make it as easy as writing a unit test. So we provide a lot of tooling to allow the developer to think the same way they think about like standard testing, like unit testing, when they write these fuzz tests, which has, I think, been a large problem that we found is fuzzers work on bytes. And that's really annoying for developers to think about. How do I convert these bytes into the types and structure that I need? If you're writing some JSON, it's really unlikely that the bytes you got from the fuzzer are going to convert directly into some proper JSON. So we provide a lot of interesting tooling that developers can use to just say, I just want some JSON, and just fuzz the data within that. And then, they write this simple fuzz test that they can run locally, but they really don't have to, because they just push it up to, GitHub, GitLab, whatever, and we'll pull it from there and basically just start fuzzing it on our server. So the developer is actually pretty far kind of removed from the underlying infrastructure that's required to actually run these tests. They can just have, they just have to say, like, these properties need to be fulfilled. This is the application, this is the function I want to test, in this structured, protocol or whatever grammar. And then that's it. And then we take care of everything else.
Yeah, that answer. Oh, Matt, did you have a follow-up?
Sorry. Yeah, two questions. You're touching right on something that I've been thinking about. I think, and you've talked about this a few little points during the interview, but I think it's interesting enough. I want to keep digging on it. Historically, one of the issues that people have with fuzzers is just setting them up and getting them going, right? I mean, it's usually not a fun process unless it's something, it's a pretty heavy context switch for either a security person or a developer, because you're coming at both. And it sounds like you've got some tools in place there to really make that easier, right? I mean, you're using the JSON example, so I'll stick with that. Can you talk a little more about how, if I put my developer hat on and I come in and I've got like some application which is taking, say it's got an API, it's an API server. What does that process actually look like, sort of, the 15-second version of it?
Sure. So that's actually something we've spent a really long time on, is how can we make that process simpler, right? So right now we've got Go and Rust, where, so for Go and Rust, we've got this working. We want to expand it to other languages. We're pretty confident we can get it on C and C++ this year. And the idea there is you actually don't have to write any code to start fuzzing. So with Go and Rust right now, you would just log in, you'd connect your GitHub account, we'd pull in, you'd see all your code, you'd click on the repo that you want to fuzz, and then what we do is we do a quick analysis on it where we scan it for kind of all the functions that you've got, the different kind of trying to understand a little bit how your application works. And then we'll list all of those functions to you. And, these are functions that you're familiar with, some of, ideally the ones that you've already written. And you just have to click on them. And then you just click fuzz. And then behind the scenes, what we're doing is doing all the heavy lifting, right? On the instrumentation side, on the fuzz harness side, right? Like actually generating that fuzz test for you. And that's it, right? You click fuzz, and then we'll pull your code, we'll build it on our servers, and then we'll immediately start fuzzing it. And this is a really good way to just kind of do the 0 to 1 process, right? Like you have no idea what fuzzing is, you've never fuzzed before, you don't want to spend a lot of time on it, but you're kind of intrigued, right? You just have to click through some quick setup flow, doesn't take more than 5 minutes. Honestly, the largest factor is just how long it takes to build your code. So if your code builds, in like 30 seconds, then it won't take you longer than, I don't know, 3 minutes to go from 0 to actually fuzzing something. And you won't have to write any code. You don't have to think about what it's doing under, how it's like instrumented or how all this stuff is happening. You just click through it. And we found a lot of bugs just doing that. So honestly, like we've kind of, the way we test it ourselves is we'll just go in and pull a bunch of GitHub kind of open source GitHub projects, and we'll just click on all the functions that we want to fuzz, and then we'll just fuzz them. And that already in and of itself finds a lot of bugs. If you're not fuzzing your code, bugs tend to pour out the first time just because there are a lot of things that your developers aren't testing for. Once that process is done, then we have like these tools that kind of allow you to help you write these fuzz tests. So you can think of like a library that you would pull into your code base and just kind of say, it's just a way to communicate with the fuzzer in a nicer way instead of just working on bytes and, telling it, chop these 15 bytes up and like put them into a string and, cut these up and put them into a struct or whatever. And so on the API side, what I would say is, you probably don't want to fuzz the transport layer, right? Like HTTP, JSON, these are well fuzzed protocols. It's not really interesting to fuzz that stuff. What you want to fuzz is the logic of your API. And so you would want to skip past the transport part and just fuzz directly into the handler, right? And so you can have the fuzzer basically hook into that directly and just provide the data without the JSON part, right? So usually you're working with an object or a struct, and the data would just come structured in that format, and then you just get it fuzzed into that handler. And the idea there is it goes much faster. It's a lot easier for developers to work with. They don't have to deal with looking at weird JSON payloads. These are actual objects that they're familiar with, and you just that's it. It's pretty straightforward.
Cool.
Can you do that for Python so I can get Paul to use it? Oh.
So Python is next on our list. We've got it's fairly straightforward to do. From my understanding, is just kind of because we're an early stage startup, we're focusing more on kind of what our customers are asking for. So if Paul's willing to pay, then maybe.
Good answer. So I've got one more, if I can squeeze one more in here. And this comes back to, you touched upon it a little bit there, but let's see, how do I phrase this? So thinking about that selection of languages you're supporting, and sort of, you've been in this fuzzing space for a while, you know it pretty well. We've talked over the last year or so about the type safe languages we have out there now, or memory safe languages. Like I'll stick, for example, say Go and Rust and maybe TypeScript. I think you do JavaScript, not TypeScript. I'm curious, from what you've seen in your testing and your customers' use, are you seeing the fuzzer finding less issues in these newer languages, or is it just as much of a crapshoot?
It certainly depends on
high level.
Yeah, sure, of course. It certainly depends on the application. Obviously, less or none, memory bugs. But crashes, hangs, timeouts, right? These are very severe. This is where we start to get, once you get into the memory safe territory, that's when you start to get into, how do we tell the fuzzer what kind of define some invariants to the fuzzer, some properties that should never be true. That should always be true. And so that's where it gets really interesting, right? If you've got some, if you take like a very simple like JSON library that just marshals JSON, marshals data into JSON object and then just unmarshals it, right? If you fuzz just the marshaller, you're only going to look for crashes, for timeouts. If you're just fuzzing the unmarshaller, same idea. But if you're fuzzing you send some data in, you marshal it, and then you unmarshal it, and then you check that the value that came out of the unmarshal is the same as the value that went into the marshaller, right? That produces a lot more interesting types of bugs. And again, sometimes these can be security vulnerabilities. I want to be careful and say, not all of these are security vulnerabilities, but a lot of the times they significantly improve code quality because you don't want these types of kind of bugs lingering in your code. And so going back to the marshaller and unmarshaller case, right? If you've got kind of this inconsistency between the way it's marshaled and then unmarshaled, that's not good. And so these types of bugs and vulns are the types of things we encourage our users to look for when they're actually fuzzing these more memory safe languages.
There's one aspect too I want to talk about, because you mentioned pulling in a bunch of open source projects, fuzzing them. I know Google has done this, but Google also has just about an unbounded budget to run compute resources for this types of fuzzing. Speaking of the compute resources needed to do the fuzzing and the time it may take, how do you handle that or manage that for end users?
Yeah, so I guess one thing I want to be clear about is we were fuzzing open source kind of just on our own, just for us to test our code, right? Like we are in no way at Google scale when it comes to their resources and their fuzzing efforts for the open source community. Fuzzing, Google's been huge. Like they've found, I think like 11,000 bugs. Don't quote me on that. It is public though.
It's something that
bugs,
large, yeah.
In the open source community, on very large projects, SQLite and like MySQL, all that. So when it comes to, resources, and I think that's kind of a large point for fuzzing is, fuzzing is really resource intensive. Google, I think last I heard they're fuzzing on like, 20,000 VMs, right? Like 24/7, like, that's not something that most companies can afford. And so what we do is we try to, balance how much fuzzing is done at what stage. So what we do is we try to use fuzzing as a way to generate a corpus or a set of test cases that basically should always be true. If the fuzzer sends in some input, triggers some coverage, but it doesn't necessarily trigger a bug, that could trigger a bug later on in the future when a developer makes a change. So we actually store all of these inputs that don't necessarily trigger bugs now, but could in the future. And so what we do is when you make a pull request or merge request or whatever, depending on your platform, we'll actually run through those previous test cases on that pull request the first thing. And so it's kind of like running regression tests, really. The benefit here is you're using previous fuzz runs to test for bugs again without having to actually run an entire fuzz test job. When it comes to running on master or on main, we want to fuzz as much as we can continuously. And so a large part of this just comes down to how much the customer wants to spend on compute. So if the customer has 10 VMs that they want to fuzz on, but they have 20 fuzz targets, you can imagine it gets really slow if you're fuzzing 20 targets on 10 VMs. And so what we do is we use some proprietary algorithms that basically detect how far along the fuzz tests are statistically, and then kind of deallocate resources to those and reallocate resources to things that are kind of less further along. And the goal is to try and get kind of equal coverage, equal kind of testing across all of the fuzz targets. That's a work in progress, but I think that we've seen a lot of people get really excited about that because it means you don't have to fuzz continuously forever. And if you've been fuzzing for a couple of months, right, like chances are at that point, like you're less likely to find things. We've still found things, but we're just kind of optimizing here for cost more than anything because we're not Google.
Oh. No, but and you're kind of talking about that's what you're working on over the upcoming months. I'm just curious, what do the next few months look like for you? What does 2021 look like for you and for fuzzing?
Sure. For us, we're constantly just trying to improve the developer experience with fuzzing. So, making it easier. Like I said, we've got it working for Go and Rust, kind of just click through fuzzing. Python is next. Click through fuzzing for Python might be a little bit trickier just because there's no types. So we'll have to kind of do like some work around there. So definitely on the easy side, definitely increasing the class of bugs that we find. So one thing that we started testing with and we've seen it work really successfully, and we want to kind of extend this, is floating point, like fuzzing against floating point math, and kind of anywhere you're using floating points, checking that things are kind of the math checks out, right? That's fairly interesting and can lead to vulnerabilities, but certainly lead to just kind of bugs that you don't want in your code. So that's kind of one thing that we're doing is I'd like to call them maybe sanitizers. And so just building more of these sanitizers out that we can use to find more interesting bugs with less effort from the developer, right? That's something that we're focusing on this year. And then, in the fuzzing community, I think they're starting to catch up on like making tools easier to use. I think there's still a very large focus on making them more effective. I think, more effective fuzzers is really useful. but if no one's running them, then they're actually not more effective at all. So our goal from Fuzzbuzz is, right, let's get people using them, and then let's make them more effective. And we're constantly looking at the research that's coming out, around making it, squeezing out just a little bit more speed, or adding some algorithm that goes a little bit, a little deeper into your code base or something. We've also seen an interesting rise in grammar fuzzing. So if you can define a grammar for it, you can try and fuzz within that grammar. That, again, gets a lot of interesting results if you've got these weird, obscure protocols or definitions of kind of specs that you need to use. So I think that's probably where we're headed in 2021. But we'll see. Cool. It's kind of early.
We'll see. Yeah, well, I think we're also going to have to demonstrate the halting problem right now and bring this segment to an end. So, Andrei, I do want to thank you for joining us. This was a great talk about fuzzing.
Yeah, it was great being here. Great to talk about it, and I hope more fuzzing in the future.
Hope so. You also dropped the phrase fuzz run, so I'm trying to think through what type of synthwave subgenre fuzz run is going to be. So thank you for that as well. Also want to thank Matt and John for joining me, and thank all of you for listening. We're going to take a quick break and return with the news of the week.
Application security is hard when security is separated from your DevOps workflow. Security has traditionally been the final hurdle in the development lifecycle. Iterative development workflows can make security a release bottleneck. With GitLab, security is built into the CI/CD process. Every code commit is automatically scanned for security vulnerabilities in your code and its dependencies. Results are delivered to the developer in their native workflow for rapid remediation. Learn how GitLab enables DevSecOps. Visit securityweekly.com/GitLab for a 30-day free trial.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. Learn how to conquer cloud complexity in our first Security Weekly webcast of 2021 on January 28th at 11 a.m. Eastern. Register at securityweekly.com/webcasts. If you missed any of our 2020 webcasts or technical trainings, they're still available at securityweekly.com/on-demand. Speaking of missing things, if you did miss Security Weekly Unlocked last month, back in December, you can now access all of the content on demand, whether you registered before the live event or not. Just visit securityweekly.com/unlocked and click the button to register or log right in. And now we have some news. And riffing off of my Muppets intro at the top of the segment, why are there so many vulns about repos and what's on the other side? So we're going to start off talking about source code once again. Last week, John and I, Matt, I don't know if you had a chance to listen to us, we talked about Microsoft source code being accessed, and we kind of posited that that was a compromised credentials from an insider attacking it, and that Microsoft's threat model, covers the fact that adversaries may have access to source code. In this case, we have an article about Nissan, source code leaked online after a Git repo misconfiguration. So here's possibly, even if you do have your source leak or access to your source as part of your threat model, you still probably don't want to be having admin as your GitLab repo configuration.
Yeah, well, so the Microsoft case is probably a little more advanced because, we talk about SolarWinds and all the underlying components that probably led to that source code breach, by the way. In this case, it's just a simple misconfiguration. And, I don't want to beat on a drum. I already threw the Buckeyes drum in there today. But we're back down to misconfiguration again, right? It's not that sexy thing, but we've talked about a lot of misconfigurations over the past couple of years, especially in cloud environments. Now it's in the repo. When you misconfigure this stuff incorrectly and things get leaked, here we are again.
Yep. You don't have to be worried about the nasty APTs, those threat actors, when you're just going to misconfigure a repo and make it public. And that's one of the things, too, is the question of what can GitLab, GitHub, for that matter, these types of cloud service providers do basically to make this harder. Because I know, what was it last year? Amazon made a change. It's actually for S3 buckets that you actually have to jump through a lot of hoops to make an S3 bucket public. And here, once again, is probably the same type of thing that these cloud with repo service providers could be considering as well, because these types of, even if you have admin, these types of misconfigurations are pretty consequential, at least from an intellectual property perspective.
And we know GitLab's been doing a lot on the security front as a sponsor. They're bringing a lot of capabilities in. So my guess is they're looking at similar ways to look for some of these misconfigurations within the repos as well as looking at your code and all the other things that they're doing. So I would expect, if the capabilities don't exist, you'll see them very soon from some of these providers. But this is a common, it's a human error. I mean, this is human stuff, right? And we'll get. I think there's some more detail on a couple of these articles around aspects of this, but it's just looking for some of the basic stuff like username, password, simple configuration stuff that generates these breaches, which is just, some days it just seems silly.
So this is this was an on-prem installation, and this is sort of one of those gotchas, right? So someone went, they had an on-prem Git install, whether I know GitLab, whatever it was, but they came down from the point of view of, we're not going to put it in the public cloud because we want to be secure, so we're going to run it ourselves. And here we are, right? But so this is from anti-proprietary. I've mentioned these guys a few times over the last few months. So someone told them about this particular one, but they've been going out poking and scanning and looking for open Git repos for months. And we and many other folks are telling people, hey, you got to tighten your shit up. Should this even be public on the internet in the first place? Pardon my French there, by the way. But we're going to see more of it. So this is a pretty good example of maybe you don't want to be running some of these things yourself and want to be using a public cloud. I think GitHub has a pretty good track record themselves right now of security. Mm-hmm. So yeah, it's.
And John, the French would be merde.
Thank you.
We're aiming for that explicit label in as many different languages as we can get. So yeah, thank you. But I think, to your point, I think the only thing I can add at this point now too is that finding this type of vuln isn't even, or this type of misconfiguration isn't even that difficult, I would think too. It's sort of a known quantity, if you will, to be able to scan for a URL. Is this a common GitLab, GitHub URL, or a source repo URL? And can you throw in a dozen or so, common credentials? Yeah. Admin being kind of one of them. So yeah,
it's a standard credential stuffing attack. I mean, it's like, is it open? Yeah. Okay. Let me just throw a bunch of standard credentials at it and see what works.
Yeah.
Done.
Yeah, done. So that takes that's some open source. Basically takes 10 minutes of your time to stand up a scanner and go run for that. At the other end of the spectrum, what might cost you at least $10,000 of equipment and a little bit more time is some cool, speaking of, I believe, French researchers, looking at Google's Titan security keys. And again, this is a really neat write-up. It's a good 60-page write-up. So those of you who are in our Discord channel talking about having trouble sleeping, I'm sure reading through 60 pages of a security write-up can put you to sleep. Now, that's not to take away from the cool content within it, because what's neat about this is that it fits a couple things of the themes that we're trying out for this show. One is let's find out some examples of good security write-ups. This is definitely a bit long one for 60 pages, but it also does a good job of not only diving in some neat hardware, some analysis, as I mentioned, I think it was 10,000 euros, sorry, of side channel equipment. So side channel also speaks to me, but they also put it in perspective. So nothing about this research is that they're saying, we know how to not only take apart a Titan security key, but clone it, which is actually pretty impressive. So now you could actually take it apart. Admittedly, taking it apart is a bit destructive, and they say you'd probably have to have a third party, a 3D printed mount to put it back together so it's undetectable, so to speak. But now you'd actually have two security keys for the same account, which is technically shouldn't be happening here. But they're not saying that the sky is falling. They're simply pointing out this is the effort that it took. So you don't necessarily need to now change all of your threat models and say these types of FIDO U2F keys are broken. It's just that these are the particular cases and mechanisms that they can be attacked. And they're, I think, doing some incremental cool research about that.
Yeah, I think in certain use cases, this is a really interesting vulnerability. If you think about federal government, you think about top secret programs where you're using hardware, FIDO keys to decrypt stuff. This is a really interesting threat model to think about. For most of us, this is probably not worth it because it's like, in order to get this, that's a lot of money, the cost to do it. Look, you can just use admin scans and get into repos. What the hell do you need to do this for?
Right.
Absolutely.
So the one takeaway for me on this was, at first I'm like, okay, hey, this is sort of cool that someone did this. Second, who cares? But then third, I think, which is sort of coming back a little bit what you were saying, Mike, around the threat model. I think this might be interesting for some corps or for some larger orgs that, what does your policy look like when you lose or misplace a two-factor token? Do you say, like, I think I was saying to a friend, like, hey, you come back from the bars after a fun night out on Friday night, Saturday morning, you realize you don't have your keys with you. Okay, do you call the bar? Do you call work? Do you wait till Monday morning? What do you do? What sort of window do you have around that situation? Like, I mean, do you say, if someone misplaces a token, we have to have a way of reporting and locking it within 10 hours? Or I think that at least is a fun thought experiment around this.
Yeah, and I think it's very specific use cases, John, too, right? Yeah. Is if you're an agency that happens to have a bunch of top secret data and your key's missing for a period of time, this is a potential attack vector, right? But I'm not sure it applies to most organizations.
That applies to most, but it is topical because if we, as a callback to SolarWinds, this is exactly not exactly, but how FireEye discovered the initial compromise or was alerted to initial compromise was someone was registering a second authentication mechanism within Duo, and they contacted the employee and they said, "Hey, is this you within the authenticator?" And the employee said no. And lots of interesting patch cycles and news cycles have emerged just from that authentication point. So still a worthy thing to think about, as John was pointing out.
Agreed. I think that statement ties into article number 3. The Russians have already achieved this through the SolarWinds hack. What do you need Hack the Army bug bounty for? Russia wins. Give them the prize.
Well, it's only paying out in dollars and not rubles. So maybe if they want to convert it to dollars, they have to sign up for the Hack the Army. But yes, great segue. Thank you, Matt. This is the third 3.0 Hack the Army. And I mostly pulled this out as a way just to talk about a little bit of the economics of bug bounties and just kind of also pointing out how hacking or bug bounty programs are sort of evolved perhaps over time. There is in the announcement that back in November, when the Army announced this, they said, I think the first iteration only attracted 371 hackers and yielded about $100,000 in bounties. 2.0 in 2019 had 52 hackers, 146 vulns for $275,000. And so actually, in terms of the price per vuln, that's actually going pretty well. So what will be kind of interesting is just to see how many people participate. And from the participants' perspective, what is your ROI on finding a vuln? Is it, if you spend 8 hours, you're basically hourly rate for doing so. And that I think is kind of an interesting aspect because we have another couple articles coming up about the economics, I think, sort of DevOps or economics of looking at cybersecurity. So I don't know anything else on the bug bounty side there, guys. Or
we just like dead air.
I stated it.
Yeah, exactly.
The Russians have won. Sorry, it's game over.
So, riffing off of Matt's comment, do you have to be a U.S. citizen to enter this?
Probably not.
I think actually for the Army, I think for the Army ones you do. Yeah, I believe you do.
That'd be so.
But with the Russians can just go talk to China about the OPM leak and do some impersonation about plenty of U.S. citizens. So, and there we go. We're breaking John. Sorry, there comes our E for exciting for this podcast. So talking about money. Sorry, John. I'm going to take us into this next one. I'll give you first shot. The poor software quality costs us. So here is sadly yet another PDF behind a registration wall, but we register so you don't have to, so we can talk about it. But this is from Synopsys and the Consortium for Information and Software Quality, basically saying poor software quality costs us, and they do have a specific, pretty explicit cybersecurity call out within it. So I don't know, John, if there's something here you want to tackle, or if there's a different angle that you had in mind.
Oh, there's a few. One, Synopsys is a sponsor, and we're all big fans of them. Actually, I personally am. But I will say their co-authors are making this paper available without having to sign up, and I'll leave it at that. So, yeah, pretty pictures. There's one actually I really like on page 4. And it compares, it's a Venn diagram, or it could be, technical debt 1.3 trillion versus cost of bugs 2.8. And obviously one circle is bigger than the other. So I think that's sort of, again, very visually, I talk visually, but that allows me to scan through these 68 papers. Well, this one's 46-page papers and gets into the chase. But I thought that, that sort of drives it home. there's definitely, and hell, I was in a meeting already once today about this. There's always a push about, how to get software out the door versus getting something fixed or getting decent code quality, right? So I think it's good to take something like this to heart. I had never heard of this organization before. They have all sorts of good stuff on their website. So for folks out there, it-cisq.org, the Consortium for Information and Software Quality. But yeah, standards, use cases, all sorts of resources. I don't know how this one flew off my radar, but I'm going to be spending a good amount of time on that site.
Yeah, and I think this one also, it grabbed me because I thought it was a nice complement to our discussion in the last segment with Andrei about Fuzzbuzz, because a lot of what we're looking at is software quality, and security is very much is a dimension. I think we should say is a dimension of software quality rather than quality is a dimension of security. The page that stood out to me, or picture that stood out to me, if you dive into page 22, they're looking at the average annual cost of cybercrime by type of attack. And this is a little bit older data, so it's from 2017, 2018, but it talks about malware, and web-based attacks is number 2. So there's our good strong tie, especially to Application Security Weekly, that web-based attacks are the second highest in terms of where the costs are coming from, and to the point about losing those YubiKeys or losing those Titan keys, stolen devices are down there as well as ransomware near the bottom. But one of the points this article is making, or this research is making, is that ransomware is definitely on the rise in 2020, 2021. So start making sure you have backups. Start making sure you have patch strategies in mind.
Yeah, I mean, obviously patching vulnerabilities is number one on the list. I thought what's interesting, the second largest piece of the cost is legacy system problems. And as we think about kind of the transition to the cloud, do we have an opportunity to move some of these legacy systems and break some of that? It's going down slowly. But could we see some more moves away from some of these legacy systems as people move into the cloud to bring that cost component down? But patching, was a big component of this. I thought it was interesting that tech debt was outside of that number in a $1.3 trillion chunk by itself, which we've talked about tech debt on the show before and the challenges around that. That's really number 2 when you break down the individual components. It's patching and then tech debt before you even get to legacy systems and some of these other components.
Yeah.
No, totally. And I did want to also, there were 2 other articles I put into the show notes from the workshop on the economics of information security. Now, this is and I can't remember, I think this was the 13th or 14th year. Maybe it's gone longer, but it's an annual conference that is very much as the name implies, looking at what are the economics of information security. And they had 2 academic papers this year that were talking about the cost of cybersecurity. Now, they were pretty dense, and I admit there wasn't much that I was able to really pull out of them that were too strong in terms of actionable things, other than they're really good reinforcing the idea that disclosing cybersecurity investments can reduce the information asymmetries about a firm's key element of risk, which is really just saying if you're more open about where you're spending or how you're spending your money in your cyber domain, investors and insurance providers appreciate that. And there were some areas where I was talking about the cost of insurance, for example, and how that can be influenced. So I'll throw that out there for those of you who are interested in that more academic side of this research, as well as putting that WEIS, W-E-I-S, onto the radar for something to watch out. Because every once in a while, to me at least, they have something that's pretty interesting that would grab me.
There was something, it passed by one of my, it's in a tab around here somewhere that I saw last week about, it sounds like cyber insurance is starting to be picked up by orgs. If I find it, I'll throw it into just Discord. It seemed like it's sort of complementary to what you're saying. I'm not sure if it was directly related. It was off Crunchbase or TechCrunch or something. But so I'm glad to see people are taking it seriously. But my worry then is once that's sort of identifying a problem, and they're obviously seeing a financial risk to it finally. But I hope they don't go and just say, "Oh, we're just going to pay for the insurance, and not pay for the fixing the code."
That's true.
Yeah, and a lot of insurers are just adding basic cyber insurance coverage into their base packages now, which is why I think you're also seeing that trend go up, is because they're now kind of embedding just the basics in there. And really, at the end of the day, it's not enough to cover real attacks, but it's being added into some of these base policies.
Yeah.
And
it was funny, actually.
Oh, go ahead.
Just riff on that a little more. I remember a year or two ago, there was hope, and I can't remember if we recovered this, but I remember there was hope that as people started getting more into security insurance, that the insurers would actually be the ones mandating, how will I say, higher audit, higher levels of control. So I'm not sure if that's happening as I'm not sure if we're getting that cycle yet, or we're going to have to wait a little bit longer.
A few are, but most aren't.
Okay.
I bet listeners should also tune into Business Security Weekly. I bet that's where we'll get some good monitoring for that. So expand your podcast listenership, as well as you can expand your focus on 7 trends influencing DevOps and DevSecOps adoption. So looking at this, I don't know that they're necessarily trends as much as perhaps good fits for DevOps. But this is broken down into 3 particular interesting domains, areas of focus: architecture, infrastructure, and technology. And I don't necessarily think there's anything too surprising here, because, for example, under architecture, there's going from a monolith to a microservice architecture seems to be a trend driving DevOps, as well as cloud-first trend driving DevOps. I think that's pretty straightforward, but I think what I would call out to tie it back to some of our previous discussion is that breaking a monolith into microservice, or going cloud first, or just moving to a cloud, are 2 great ways to pull down that technical debt, or turn those legacy systems into more modern systems that are easier to maintain, and ideally can pull down that improve the quality and pull down that cost of ownership, or that cost of maintenance for them.
Yep, and maybe get some of that legacy stuff and bring that 520 billion down to 0-ish. Ish. Good call.
There was one thing that was in here before we go on to the next article too, that was the shift towards AI and ML. And I wanted to set that up so we could get some jazz hands from Mr. Kinsella himself. I wasn't necessarily convinced that is a shift to DevOps trend, or what that was a bit of a non sequitur to me. But I will admit there was some AI, some unsupervised learning that was mentioned in the Titan key analysis. The researchers used it as they were helping to pull out bits of keys. So AI ML exists, but I just don't know that that's the reason that's going to drive you to DevOps.
AI and ML has got to be part of everything. Otherwise, you're not doing your job.
I can only jazz hands so much. So yeah, no, it's I don't know why they put that in there. There is actually a really interesting aspect. So it turns out if you are seriously doing machine learning in production, one of the larger issues with ML and AI in general is actually how do you productionalize that? You're taking a field which was pretty purely academic, right? We know how to do this in a Jupyter notebook or things like that. That's very sort of R&D minded. How do you take that and bring rigors of productionalizing that, so you have audits around it, being able to reproduce your training sets, ensuring that your accuracy and your predictability are constant, making sure that you're actually testing around different parts of that your data set, your testing set is actually complete. So there is a lot of issues around that people are working on automating. So maybe that's what they're talking about, but that seems like a bit of a stretch.
It does. And that does remind me, speaking of the data sets, your training sets, those definitely pull in some very important discussions around access control and even encryption, because suddenly you're potentially pulling out on production systems where the workflows and functionality on the data itself, whether it's emails or just in general personal information. Turning those into giant blobs of training sets, depending on what you need from it, can also be really great things to target, just in the sense of here's a massive amount of data to compromise, or at least a massive amount of data that needs to have equivalently strict access controls around it. So good things to think about. The final article here, and this caught my eye particularly because we did reference Pokemon last week, so might as well do that 2 times in a row. We got to catch all of the articles for this, and this was pretty interesting. It's anecdotally navigating the trade-off between development speed and security, and I liked this, and I wanted to frame this in the sense that speed and security are not polar opposites. It's more of that idea of what are you doing security-wise that's enabling you to be fast with development. And I also like kind of just the open-ended questions it poses near the end. Is sort of threat modeling. What's the type of threat that you're dealing with? Are you dealing with someone that needs to pull in $10,000 worth of equipment and call out to a Discord channel and bring in some liquid nitrogen to start freezing some hardware keys? Or is your type of threat model someone with a scanner that can test for admin on your front, web-facing properties? So that ties into how likely is the exploit, what upstream protection does the company have? So these are just good ways of saying with the security team, sure, we're doing things fast. How worried should we be? And walking through those trade-offs, those kinds of threat modeling questions should hopefully help position this as just how worried should we be and go forth and write things quickly.
We talked a little bit about this on the last segment, right? Where is if you can embed fuzzing into your build process, you get security with some speed, right? And so I think this first point, automate wherever you can, is really the kind of the whole area around DevSecOps, is integrating some of these security testing processes into your development cycle. So at the end, you're getting both. You're getting a combination of both. It's not one or the other. And I think this is where we have to continue to focus, which is why I asked a little bit around the friction side, right? If it's too much work for the developers to instrument the application to get the value out of the automation on the fuzzing side, then we're not going to improve security because we're not going to get anybody to use it. And so we have to continue to see that trend moving forward in the industry where we get some of the security testing for free through automation.
Yeah, I think automation has to be that key part of it. And the third bullet, too, have regular security-focused learning sessions. That kind of speaks as much to the idea that, hey, DevOps, you're now responsible for security. But as a security org, we can't just say you're responsible and walk away. We actually have to enable them. And I don't think this also is not saying we now need to train up every single developer. So not only do they know how to write code, but they're now a pen tester, a certified pen tester. No, it's just more of they understand the tools that are being run, the fuzzers, for example, or the SAS or the DAS tools, but they also have some good concepts of what are the common types of privilege escalation attacks, or the type of injection attacks. So I think that's a good thing of just setting up the DevOps team to be responsible for security and do it in a way that they're going to be able to succeed, rather than just tell them, cool, it's your problem, we're going to walk away now.
I was a little disappointed on this one. When I saw the headline, navigating a trade-off between development speed and security, I was expecting a little less DevSecOps and a little more culture and sort of the management conversation side of things, and that just could be the hat I've been wearing recently. This is one of those type of topics also that, you can throw tools at it, but if you're not changing what you're doing, or you're not changing the culture and the thought process of the company, or whatever it is, could be open source. I don't know. And then the part at the bottom, the opt for speed, that just reads like your CVSS environmental variables. So I mean, I'm sure there's value in this article for some folks. It was a little bit of I was hoping for more, though.
I think culture is definitely a part of it. John, I think you hit on a point that wasn't brought up in the article, right? Is that without a cultural shift, none of the security speed trade-off discussion even happens, right? I know we've made some progress, and I think that's a good thing. But to your point, maybe that's kind of an underlying theme that should have been addressed in the article.
Absolutely. And I think that we'll use this as the call out to all of our listeners and everyone in the Discord channel. What are some of the articles, or what are some of the ways that you see the culture changes happening? Or let's find some articles that can keep John's interest. And that will be the homework for the week. So I want to say thanks, Matt. Thanks, John, for joining me. I want to thank everyone else for joining us as well. And we're going to see you in 2 weeks on Application Security Weekly.